All right. Day 3, lesson 3. Our learning objective today is that we're going to be able to identify key features of linear functions, including the x-intercept, y-intercept, zeros, and initial values. And here's the key, real world scenarios. Last class, we did it just in math situations. Like I was giving you equations, I was giving you graphs, stuff like that. Today, we're going to look at real world situations, and we're going to do the same math as we did last time. We are also going to analyze the graph of linear functions for real world scenarios. Okay, so with that, let's get started. You can look through your success criteria. What makes you successful is if you can identify the initial value. What's another name for initial value we learned? Anybody remember? I'll give you a hint. It's one of these key terms down here. Initial value meant one of these. The y-intercept, good. Go ahead and connect those two words. Initial values and the y-intercept are the same thing. Moxie, can you say that for me? Do you use that the right way? Okay. We can identify the zero of a graph. Now, okay, zero, let me change colors. Zero, what does zero mean? The x-intercept, good. The zero is the x-intercept. So take your x-intercept and draw that one to zero. Those two mean the same thing. We can calculate the slope of a linear graph, and we can calculate the slope of a line passing through 2 points. Slope had another name as well. Does anybody remember the other name for slope? No, it was rate of change. Those were your synonyms right there. Those words all have the same meaning. We'll be doing all this in linear functions. So a function was that each x has exactly one y. That was our definition for a function. Each x has exactly one y. I can probably just type that quicker than I could write it. Each x value has exactly one y value. That was our definition that we were working with last time for function. Okay, so I'll put that right there. All right, with that, let's get started with a new lesson. Okay, last class, I gave you this vocabulary sheet. Now, today I'm taking away to see who can remember what the definitions were. So the first one, raise your hand if you think you know it. There were two names that describe the ratio of the change of the y-coordinates, which we call the rise, to the change in the x-coordinates, which we called the run. There were two words. If you remember, two phrases, I should say. If you remember either one of them, raise your hand. For what does it mean? What math word means the ratio of the change in the y-coordinates, the rise, to the change in the x-coordinates, the run? Just show of hands. Who remembers what one of those words was? Rise or run, that ratio. Y to Leah. Okay, you're thinking right. What I meant is one of these words that's right here, one of these words that's down here means it's the ratio of the rise divided by the run, or the rise over run. Which one of those words meant rise over run? Slope. Slope. Julia says slope for one, and Kiko, I heard you. Your first blank on the left is slope. And another name for slope, Kiko said, was rate of change. Fill that one in on this side. Rate of change. Both names work. Okay, how about this? So those two students are out. Julia and Kiko are out, so we've got to depend on the rest of the classroom now. The point where a line crosses the x-axis of a graph. It's always in this form. What do we call the point where the line crosses the x-axis? What do we call that point? There are two different names. Show of hands if you think you know one of the two. All right. Ariana? X-intercept, that is one of them. X-intercept is one of the names. Good. Anybody remember the other name? Moxie. Zero, perfect. You got it. Zero is the other name. And finally, the point where a line crosses the y-axis of the graph. It's always in this form. What is the point called that crosses? Deja. The y-intercept, that is one name. There is a second name. Who can remember the second name? Leah. Oh, rise over run is the slope. It's a different name for
Initial value.
initial value. There you go. Good job correcting yourself. There it is. Initial value. Perfect. Now you've completed your vocabulary chart. This is just to help you remember what the words mean without you having to write the full definitions. Okay? So those are our key words that we'll be using, the words to describe the key features of these graphs. Those are the words that we're going to be using today. All right? So there's your vocabulary for you. Last class, we had an exemplar. We just walked through some points to make sure everyone understood what everything is. Let me start with this blue point right there. That blue point, when you look at it, that takes a name. It's either the x-intercept or the y-intercept. Which intercept is this blue point? The y. Come over here and put y-intercept. Notice it's a blank. Make sure you put that is the y-intercept. Now, what are the coordinates in terms of an x value and a y value to describe this blue point right there? Like, what is its x value? Good, because when you look at the x-axis, it is straight in line with the value 0. That's the x value. And then what's the y-axis value? 2. Perfect. Well, if this is the y-intercept, this one in red, what must that one be? X-intercept. So we'll put that back up there. That is our x-intercept. Now let's describe its coordinates. What is the x value of this red dot? 3. What is the y value of that red dot? 0. Perfect, you got it. Now, just for extra practice, I came up with 2 extra points. These are just random points on here. Let's describe this one here that's written as x1, y1. This is just an extra point, just for extra practice. What's the x value at that point? 6. By the way, that point has no special name. It's just a point on the graph. Nothing special about it. You're correct. The x value is 6. What's the y value? -2. Great. Which leaves us with one more point of practice. This one right here in this turquoise color. What's the x value there? -3. And then what's the y value? 4. Y'all did that perfect. Now, those are some of the names you'll see, x-intercept, y-intercept, but there's other names. How about this? What vocabulary word means rise over run? What's the name that means rise over run? Vocabulary word. Slope. Very good. Slope, or there's another name for it. Rate of change. Great. I don't have space for rate of change, so I'm going to just put slope. Or how about this? I'll go like this. Slope, or I'll put it up here. Rate of change. You could also say rate of change. It's the rise over run. Now let's find out what our rise over run is. We need to pick any 2 points. Which 2 points? Just call it the colors. Which 2 points do y'all want to look at? Turquoise, blue, red, or orange? Red and? We got to pick 2 of them. I hear red and blue. Let's look at red and blue. You always start on the point that's on the left. Okay, so which one's on the left, the red or the blue? No, which one's on the left? Blue. Let's start at blue. Is our rise positive or negative if we need to go down? Negative. So our rise is going to go down. That means we have a negative rise. How many units down do I go from the blue to get in line with the red? 2. So come over here and put -2 for our rise. Our rise is -2. Now the run is always positive. It's always going to go to the right, therefore it's always positive. How many units to the right do we go to get to that red point? 3. Very good. Now that's going to be a positive 3. The run is always positive, which means my slope is -2 divided by 3. Can I reduce that? Can any number other than 1 go into both 2 and 3? No. So that's what it is. Now here's what this means. This means if we picked any point whatsoever, I'll just use a turquoise. If I go down 2 over 3, I should hit another point. Down 2 over 3. Notice how it hits that one. Down 2 over 3. Hits the red. Down 2 over 3. Hits this orange. Does that make sense how that's working? Okay, that's what the slope means. Here's another vocabulary word. 0. Zero. What does zero mean? Zero. Jose, do you remember what zero meant? Your answer is correct. So what did it mean? Zero is the same thing as what other name? Got it, Valerie. The x-intercept. Very good. The zero is the same thing as the x-intercept. The answer was 3. Okay, and Valerie, do you remember another name for initial value? Yeah, you're pointing at the y-intercept. I agree. It's the y-intercept. What is our y-intercept value? 2. So we could say the initial value is 2. When it comes to writing an equation, we will write the equation in the form y equals mx plus b, where m is the slope. I need to put up here m equals the slope. M equals the slope. And the initial value is your b. The y-intercept is your b. So this equation would be y equals, what was our slope on this problem? -2 divided by 3. I'll put the negative out front. It doesn't matter. But the negative always goes with the top number, never with the bottom. X plus, and what was our b value? 2. That would be our equation right there. That equation, if we put it in the calculator, would create that same line for us. So that's our exemplar. If you have any questions today, go back and look at that slide. That slide walks you through everything you might need to know. Okay? Let's start with example 1 now. Example 1. I'm going to give you a moment to finish writing. Like, pause this. Example 1. Now, today is all about understanding the real world problem. It says the water level of a river was measured each day during a 2-week period. How many days are there in 2 weeks? 14. Good. Look down on this graph. What? You see how it goes from 0 to 14 here? That is the number of days because it's 2 weeks. Everybody interpret why I did that? Okay. Now, let's come back over. The graph models the linear relationship. Linear just means it looks like a line between the water level of the river and the number of days the water level was measured. First question for you. What was the water level on day 8? Go ahead and take a look. What is the water level on day 8? The question is, on what day, what was the water level on day 8? Show of hands, how many of you are ready for the answer? You know what the water level is on day 8? Have you found it yet? Okay, take a look, take a look. What is the water level on day 8? That's what you're looking for. Give you a few seconds. All right, answers in 5, 4, 3, 2, 1. 18 is what I'm hearing. Let's check it. I only heard a few students. When I do a countdown, I expect everyone to participate, please. Here's day 8. There's day 8. That's where the graph is located, right here. This is day 8. On day 8, if I drag it over now and I follow, you can use your ID badge or you can just kind of draw it like this. You get a number between 16 and 20. What number happens between 16 and 20? 18. And the unit's in feet. So we're going to say 18 feet. That is the height of the river on the 8th day. Now, the next question here. As the days go by from day 0 to day 14, is the water level increasing or decreasing? Why is it increasing? How can you tell? Because the graph is going up, it is increasing. The graph, the water level is increasing since the graph goes up. Okay, I'm going to shrink this so you can see what I wrote. There you go. Still a little bit big. Let me make that a little bit smaller so you can see it better. The water level is increasing since the graph goes up. From left to right. Okay, now it asks, what is the maximum water level And this it says approximately. That just means you can kind of round it if you need to. What do you think is the maximum? That's the key word here. Maximum water level. Let's do a countdown. 5, 4, 3, 2, 1. Some people are saying 19. Some people might be saying 20. I'm going to use a little tool here to help me. What I would do is I would go from this point over. Now, 19 would be right in the middle. This is more than 19, but it's not quite 20 either. What do y'all want to say that's more than 19 but less than 20? 19 would be perfectly in the middle. 19 would be right there. That would be 19. That's more than 19 but less than 20. What should we say? 19.5. Let's say it's 19.5 feet. Now, what did maximum mean? On a graph. Sorry, does it mean like the highest, the lowest, the most to the left, the most to the right? The highest. When you see maximum, that means the highest point. That's what that meant. So we were looking for the highest. That's why I chose this one, and we went to the y-axis because it's the highest. Okay, now it says, what is the y-intercept of the graph? I'll give you a few seconds. What is the y-intercept of this graph? 5, 4, 3, 2, 1. 16. Now, when it says y-intercept, you're correct. The value is 16. When it says y-intercept, you usually write it as a coordinate point, an x comma a y. What's the x value when they say y-intercept? What is the x value of this point? 0. Good. What's the y? 16. Now, considering this is real world, they probably will not say y-intercept. Do y'all remember the other name they instead of y-intercept they could have used? Initial value. I bet you whoever made this test question, if they were after giving it 1 year and receiving feedback, I bet you they would change that from y-intercept to initial value because that's what they usually use on real world. What's the initial value? Would you still say 0, 16? If they said initial value, or what would you say the answer is if it just said initial value? 16. And we would put the word feet after it. 16 feet. That would be the best answer right there. I think they would redo the question like that. All right, so that's example 1. We did the same stuff we were doing before, but we just did it in a real world situation. Cool? All right, let's move on to example 2. Oh, bonus question. Which statement best describes the y-intercept of the graph? Is it A, the water level increased by 0.25 feet a day? Is that what that was? The maximum water level was 19.5 feet. The initial water level was 16 feet, or the water level was measured for 14 days? C. Well, I forgot I did the bonus. I'd already seen that, and I forgot I put that. Did that make it to your notes? Yeah, go ahead and put that on there. I had already noticed that, and so I threw this on there. That's what the y-intercept represents in a real-world problem is the initial value. In real-world problems, we only look at the first quadrant, and so the y-intercept becomes your initial value because it's the farthest to the left. Okay, so with that, let's move on now to example 2. It says here, the graph models. Am I moving too fast for anybody, or are we good? Good. The graph models the linear relationship between the number of monthly payments made on a loan and the remaining balance in dollars left to pay on the loan. So notice the x-axis is, what does it say the x-axis is? Number of payments we've made. And then over here, remaining balance. What does that mean, remaining balance?
Oh.
Like how much you still owe the bank. Each month, it's how much more money you still owe the bank before you totally paid it off. Okay? First question. Can we tell approximately how much the initial loan amount was? Can we tell how much was the initial loan amount? Could you be able to tell me what the initial loan amount was, or approximately? That means kind of guess. What do y'all think? Ivan, do you think you could figure out what the initial loan amount was roughly?
Y-intercept.
The y-intercept. All right, let's go to our y-intercept here. The y-intercept is, whoops, the y-intercept is right here. So this one says approximately, so that means we're going to just give our best guess. And this is in money, so I'm going to do dollars. What do y'all think that number is? 27,000? Y'all okay with it guessing 27? Kiko says 27,000. That was actually what I was guessing. So let's say it's $27,000. That's our initial loan amount. Now, the next one does not say the word approximately, so we should be able to get a perfect answer. How much was the loan amount after 35 monthly payments? After 35 monthly payments, how much was the loan amount? Carla, do you know? She says 11,000. Would y'all 100% agree with that? I would say she's really, really close. It is this point right here where she was looking, but it's not quite 11,000. What is it? It's written right here. 11,250. That's the perfect amount. 11,250. Now, this kind of looks weird with this comma here. Truthfully, that's the X value right here. This is tricky. This is the X value. This is the Y value. They just put the comma in there. That's the Y value right there. It's 11,250. That was for the because it was money. They shouldn't have done that. That was just bad math. That makes it look confusing. So I'm going to cover up this comma. It's 11,250. That's what it should be right there. All right, questions over this real world problem? All right, now number 3. So we have 3, 4, and 5 that we're going to talk about this example 2 here. It says 3. What is happening to the loan amount after each payment? Is it increasing or decreasing? What do you think? After each payment, is the graph increasing or decreasing? Decreasing. How do you know it's decreasing? Because the graph is going down. The loan amount is decreasing after each payment. And how did you know that? Since the graph is going down from left to right. Since I have more room to write, I'm going to put that in there from left to right. You always go from left to right. And you're 100% correct. The graph is decreasing. That's the key word there. It is decreasing because the graph is going down as you look from left to right. Now, let's go with Edgar. I haven't called on you in a little bit. For number 4, let me pause this, give you a second to finish writing. Okay, back on. Number 4, Edgar, it says, what is the zero of the graph? Help me out. What is another name for zero? And you can look back if you need to on, I think on page 2, you had that slide that told you. Another name for zero. X-intercept, yeah. What is our x-intercept? Let's go look. But when they say 0, you don't have to do the writing it as a coordinate point. That's so ugly. Let me try writing that one more time. You're going to look for the x-intercept. So look back on the graph and discover what is our x-intercept. So looking at this graph, where is our x-intercept? Ah, perfect. Perfect. The 0 is equal to 60. That's it. This is it. The 60 is our x value. The y is 0. But when it says 0, you don't have to write it that way. You can just say 0 equals 60. And in this case, 60, what's the units? If you looked on there, is it days, hours, months? It's months. 60 months. That means it takes 60 months to pay off the loan. Now, if it said x-intercept, how we would have written it different is we would have said 60 comma 0. That's how you would have written it if it said x-intercept. But because it says 0, You write it like that. That's our answer right there. Okay, last one. Which statement describes the x-intercept of the graph? The x-intercept is 60, which represents the initial balance in dollars of the loan. Is that true or false? Is the x-intercept at 60? Yes. Is that the initial balance of the loan? Is 60 how much we initially owed the bank? No, that's not it. That's not the initial balance. Though this part was true, this part was wrong. Okay, how about B? The x-intercept is 27,000. No, that is not true. That might be the initial amount of the loan. That's the initial balance, but that's not the x-intercept. Okay, how about C? The x-intercept is 60. Is that true? The x-intercept is 60, and which represents the number of monthly payments needed to repay the loan. Was that what that was? The number of monthly payments? Yeah, that's it. So the answer is C. These two were wrong. And what's wrong with D? That's not true at all. That's not true. Okay. Let's look at one more example before it's your turn to start trying some. Okay, one more. Let's look at example 3. It says a track athlete told his friend that he could give the friend a 2-second head start and still beat him in a 100-meter dash. The graph below models the track star's run. Oh, I have a typo here. The track, there we go. The track star's run, okay? So here's the run modeled on this graph. Question, what point best represents the head start? Wait. What was the head start? Read up in the problem again. What was the head start? 2 seconds. Okay, so what point represents the head start? 2. What do you mean when you say 2? Use a vocabulary word. So 2's a number. 0's one way. And what's the other word for 0? X-intercept. Yeah. This point right here, the point that would best describe it is the x-intercept, or you could also call it the 0. Since it says point usually means x comma y. I'm going to go with x-intercept. So what's the coordinates for this one? What's the x? What's the y? 2 comma 0. Yes, that's the point. That's a coordinate point that represents the head start. Why did the time start at 2 seconds? He let the other runner run for this amount of time, but then he started running. Okay. And I say he, it could have been a she. At what point best represents when the track star reached the finish line? Which point represents the finish line? 90? What do you mean 90? So if it's a point, it's an X and a Y. So where are you looking for when they reach the finish line? I hear 14, that's the X. So you're talking about this point? 14 comma 100. That point would represent it. It would be 14 comma 100. This doesn't have any special name because it's just a random point on the graph, but that is the finish line. Now, how could I know it was the finish line? Up in the problem, how long did it say he's going to run? 100 meters. And this over here is distance. How many meters has he ran at that point? 100. Yeah, that's it. Okay, how long did it take the track star to run the 100-meter race? Oh, I tricked you. Yes, I finally tricked you. You guys have been so smart. It doesn't actually take them 14 seconds to run it. Not 16 seconds either. What time did he start? 2. What time did he finish? No, that's how far. 14 seconds. So how long did it actually take him to run it? Deja says it. How many seconds did it take to run it? 12 seconds. Why is it 12 seconds again? How did you get 12? If we started, if the start time was 2 seconds and the finish time was 14 seconds. How long did they actually run? You would say the race or the run was actually 14 minus 2, which equals 12 seconds. There you go. 12 seconds is the answer to this one. They ran for 12 seconds. All right. I have worked through finding key features on real world problems. You've seen me do it. I have a DOL for you to now start. I want you to take a look at DOL number 1. I'll give you just a second longer to write. All right. Here's your first 3 DOLs. This word problem, do DOL number 1, 2, and 3. If you're watching the video, just pause to get the time until you get your answers. DOL number 1, 2, and 3. Now, before we practice, we're going to review 2 questions here. This time, we're going to find slope. We did this last class, except I did not give you just points. I want to review this. I call it review because it's still rise over run, but we're reviewing and it's not real world. But I want to make sure we know how to do it with just given points. So here, slope. Go ahead and write this, please. Let me make this bigger for you. Easier to see. Slope is the same thing as your rise divided by your run. Now, with your arms, I want you to show me which way does rise go. With your arms, does it go left and right or does it go up and down? Show me with your arms which way rise goes. Which one's rise? Up and down. Which variable does up and down? The x's or the y's? The y's. To find your rise, you're going to subtract one y value from the other y value. So I'm going to list this as y1 and y2. The x values will be the run. I'm going to label those x1 and x2. So here's how our formula is going to look. So there's my 2 points that they gave us. What we're going to do is we're going to take the second y value and subtract the first y value for the rise. The run does the x values. We'll do the second value minus the first value. And this is how we'll get our answer. So to try to be quick here, let's plug in our numbers. Which value do we have labeled as y2? 5, look up here. It's one of these 4 numbers. Which one is labeled as y2? 5, 4, 3, 2, 1. 17. Perfect. Formula says it's 17 minus. Now find y1. 5, 4, 3, 2, 1. Not just 11, negative 11. We'll fix that in a second. Just leave it there for now. Now, x2. What is x2? 5, 4, 3, 2, 1. Negative 9 minus. Formula says minus. Now, what is x1? 5, 4, 3, 2, 1. 17. X1 is 5. Now, what we're going to do is reduce. Does anybody know what happens when you have a negative next to a minus? It goes positive. So this is 17 plus 11 more. Mental math time. 17 plus 11 more. To make it easier, what's the 7 plus the 1? 8. And then you add the tens column. What's this 10 plus this 10? 2 for 20. So it's 28. Okay, down here we're subtracting. We have a negative 9 and minus 5 more. I want you to think of a number line. So negative 9 is to the left. We have a negative 9. And then we have to go left 5 more units. 1, 2, 3, 4, 5. What value is that? If you are already negative 9 and then you subtract 5 more. So we go left 5. So this is negative 9, negative 10, negative 11, negative 12, negative 13. What do we get? Negative 14. Now that's our value, but I look over here and I don't see that answer, which means it must be simplified. What number can go into both 28 and 14? 7 goes into both, and a bigger number. I heard 2. 2 goes into both, 7 goes into both, and a bigger number. 14 can go into both. How many times does 14 go into 28? 2. How many times does 14 go into negative 14? Negative 1. What is 2 divided by negative 1? Negative 2. That's our answer. Okay, I want to do this one more time so you can see it one more time. What is the slope of the line that passes through these 2 points? So we're going to do this again. Slope. When you hear slope, what should you think of? Rise divided by run. Okay, is the rise the y values or the x values? Show me with your arms. What does rise look like? Up and down or left? Okay, are y'all showing me x values or y values if you're going up and down? Y values. It's going to be a y value minus the other y value. The run will be an x value minus the other x value. Okay, so remember, y2 goes first. Let me just write it out so you can see it again. All right, we're first substituting in y2. What's y2? 5, 4, 3, 2, 1. What is y1? 5, 4, 3, 2, 1. 7. Perfect. Okay, x2. 5, 4, 3, 2, 1. Minus, now x1. 5, 4, 3, 2, 1. 26. This will reduce 12 minus 7. 12 minus 7. Mental math champion in here? 5. Good math. That is 5. Denominator, negative 39 minus 26 more. We need a calculator for this one. How about I just tell you? That is negative 65. Now, based off that, you can actually eliminate 2 answer choices. Is this going to be a positive answer or a negative answer? Negative. It has to be a negative answer. And not only that, it's going to be A because the bigger number is in the bottom. 5 goes into both of those. 5 goes into 5 one time, and it goes into negative 65 negative 13 times. So the answer is A. All right, which would take us to our last DOL. Let me go out here and I'll pause the video and let y'all work on that. If you're doing it at home, just pause the video. We're going to graph the linear function g. It passes through these points. We'll graph the points first and then determine the slope. And that's a wrap for the lesson.